All right, problem 2 of the free response section of 2023 AP Calculus AP exam. So again, these are my solutions, and the official solutions won't be out for a few months. So you've got to trust me, you got to trust that I know what I'm doing. But if you have any questions or, wondering about something, just leave a comment in this video and let me know what's going on. All right, so problem 2, we got Steven swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Steven's velocity is modeled by v of t equals 2.38 times e to the negative 0.02 t times sine of pi over 56t, where t is measured in seconds and v of t is measured in meters per second. Find all times in an interval between 0 and 90 at which Steven changes direction. Give a reason for your answer. Okay, so let's remember that velocity is a number that tells you not only speed but direction. So if velocity is positive, it's moving in the positive direction, which is usually forward, depending on what what you're talking about. But if velocity is like negative, it still could be moving at the same speed. As I say, if it's like negative 10 versus positive 10, they're both moving at the same speed, except they're just moving in opposite directions. So that's what you have to pay attention to. So you just want to see essentially, when does velocity change sign? So what we can do is graph this function, which I did. And this inspired calculator, already, saving you some time. You look for the, intercept. And here, I highlighted it as 56 seconds. See, so velocity changes from positive to negative 56 seconds on that interval from 0 to 90. So then it's only going to be there. And we can just say because v of t changes from positive to negative here. All right, B, find Steven's acceleration at time t equals 60 seconds. Show the setup for your calculations and indicate units of measure. Is Steven speeding up or slowing down at time t equals 60 seconds? Give your reason for your answer. Okay, so acceleration, remember, describes how speed is changing, or how velocity is changing, I guess. And when velocity and acceleration are working together, that means their signs are going to be the same because their force is both in the same direction. So when velocity and acceleration are both positive, you're speeding up. You're speeding up in that direction. If they're both negative, you're speeding up in the other direction. But when they're opposite signs, doesn't matter which is which, as long as they're opposite, you're going to be slowing down because they're fighting against each other. They're going, there's like, they're basically tug of war in there. So you want to see what the acceleration is at this point in time. See, and we really just care about the sign. So what we can do is we go to our calculator and we can just essentially menu, use the calculus function, numerical derivative at 60. And we find that, we have to plug this in. Hey, just make sure I don't mess up, all right? And we get negative 0.036. Now, see, who cares if it's really small? As long as it's negative, that's what we have to pay attention to. And since the since velocity is also negative at that time, which we can look at the graph here. See 60 seconds, we can highlight it, but if you wanted to trace it, but you can clearly see that the graph goes below the horizontal axis at 60. So since they're both negative, you're speeding up. And that's not speeding up by that much, but he's technically speeding up. So I'll try to squeeze that in there. V prime of 60 equals about 0.03601623. And it's going to be meters per second squared. I'm going to make you finish the answer here. Speeding up because V of 60 and V prime of 60 or A of 60 are both negative. Okay, C, find the distance between Stephen's position at time t equals 20 seconds and his position at time t equals 80 seconds. Show the setup for your calculations. Okay, so I see what they're trying to do here. They're being clever about the way they word this. They don't want to say they don't want to just say displacement, because I think they are sensing that when a student, when they hear this displacement, they just memorize that they just have to take the integral and not worry about positive and negative values. But they're clever and they say the distance between his position at from 20 and 6 and 80, and that is technically displacement. So remember, displacement is still a distance, or it's still a length of measurement. Like for example, let's say you go from school to home. Let's say your home is 5 miles away. Your displacement is 5 miles when you're at school. But when you go from school back to home, what's your distance between where you started and where you ended for the day? Your distance is 0. Even though you traveled to school and back, the distance traveled is like 10 miles, but your distance between, let's say your starting position and your ending position is 0. So they're trying to be smart here. I sense that some of you are probably gonna, want to, debate me on this, but I'm good with, I'm cool with that. I like debating. But let me know if you need some more clarity. But I know how some of these, graders are. They try to be clever with their wording, but they're trying to sneak that in there. But you just have to find displacement. In D, I can see right here, you're going to use distance. Anyways, so what you want to do, what you want to do here is essentially just integrate from, let me go, integrate from 20 to 80, and of V of t. And just calculate that. And don't worry about, you don't have to do the absolute value or worry about signs there. And I gotta do it again. And I calculate. You can go to numerical integral. So let's make sure I don't mess up here. So we're going from 20 to 80. Okay. 2.38 e to negative 0.02 x times sine of pi x 6 dx. Let me make sure I didn't mess up. Whoever is type this, 2.38 times 0.02. 2080. Okay, let's go. Bang, 23.389 meters, about 23.383997 meters. All right, and D, find the total distance Steven swims over the interval from 0 to 90. Show the setup for recalculation. So here, you care about the sign of the velocity. So you're going to take the absolute value from a velocity from 0 to 90 and then integrate that. Because remember, distance can be, if you integrate straight velocity, some of the positive and negative distances can be canceled, or positive and negative values of velocity can cancel each other out and mislead you. So you can actually enter this in your calculator within the numerical integral function. So I'm going from 0 to 90. And here, I'm going to see this book. This is a very powerful book. You press it, and it has all this, valuable operations. And this absolute value sign is what's going to be the key to solving this problem here. 2.38 e to the negative 0.02x times sine of pi (62.1642). Dun, 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 dun. That's how far he traveled, or how far he swam. Meters. And there you go. There's your answer. So I hope that helps. But let me know if you have any questions. And I bet you can't guess what animal this is supposed to be. So see you later.